Hello again, year 10, and today for our final lesson of this half term, we are going to be starting a new topic. It is a topic called Surds, and I will explain what they are in a short while. However, before we get started, I would like to wake up those brains of yours. We have some statements that involve square roots. And what I would like you to do is look at each calculation and decide whether you think that is true, that those things are equivalent and are equal, or whether you think it is false. So I'd like you to pause the video here, think about it for 2 minutes, as I am about to go through the answers. So which of these statements are true? Which of them are false? There are 2 that are true. There are 2 that are false. And you can do all of this maths because I've picked some square roots in the most part that you know the answers to. Let's look at the first one. The square root of 4 being 2. The square root of 9 being 3. The square root of 36 being 6. And 2 times 3 does equal 6. So that works. But what I want you to also notice is that 4 times 9 is 36. So we seem to have an idea that multiplying these numbers here for square roots works. Let's have a look at this next one. The square root of 49 is 7. The square root of 4 is 2. The square root of 53, I have not got a clue. It's somewhere between 7 and 8. But 7 plus 2 equals 9. Well, 9 is the square root of 81. So this one is definitely incorrect. This one is false. So again, we've just spotted if we have 2 square roots, actually adding the numbers under the square root, 49 plus 4 is 53. It doesn't work for the square root numbers. Let's look at my next one. The square root of 100 is 10. The square root of 25 is 5. The square root of 4 is 2. And 10 divided by 5 equals 2. So that one is true. But also let's have a look at the numbers under the square root. 100 divided by 25 is 4. So what we've quickly shown again is this seems to be working for division. It worked for multiplication and it seems to work for division. This idea that we can just look at the numbers under the square roots, and perhaps that isn't a surprise because multiplication and division are inverses of each other. So it worked for one, it worked for the other. Let's have a look at this subtraction. Square root of 81 is 9. Square root of 16 is 4. Square root of 65, well, that's almost 8, because the square root of 64 is 8. But 9 take away 4 definitely isn't 8. So this one is false. So although 81 take away 16 is 65, the square root of 81 take away the square root of 16 isn't the square root of 65. So it isn't seeming to work for addition or subtraction, but this idea did work for multiplication and division. So, as I alluded, we are starting a new topic today. If you've managed to print out a note sheet, great. If you haven't, it is a title, it is a date, it is an objective in your book. Since it's a new topic, I'm going to be introducing this with a few sentences and a bit of new vocabulary that I will be expecting you to write down into your book. So we are looking at the topic of surds. And surds is basically maths with square roots. Pretty much what you were just doing a minute ago in that starter activity where you started to spot a few patterns. So a surd is a way of expressing an answer using a square root. Well, why would you do that? Well, the reason being, we know that some square roots aren't particularly nice numbers. They aren't always integers. The square root of 4, 2, is a nice number, but the square root of 3 isn't. We know from Pythagoras' theorem, for example, when we do the square root of a number, quite often it is a nasty decimal. And it is a nasty decimal that goes on forever. And these can be described as irrational numbers. So we have irrational numbers that are numbers as decimals that go on forever. And we have irrational numbers. And rational numbers are numbers that are whole numbers or terminating numbers. You might be wondering, is 0.3 recurring then? A decimal that goes on forever in a rational number? And the answer to that question is actually no. If you can write a number as a fraction, that is still a rational number. So the main objective for today is being able to simplify a surd. A little bit like how you might perhaps simplify a fraction. However, when we simplify a surd, the goal of simplifying a surd is to try and make the number under the square root symbol as small as possible. How are we going to do this? Well, we need to look for numbers that multiply to make the number under the square root. But more importantly, we need one of those numbers to be a square number. So do make sure you know some of your square numbers today, because they will be super useful. It might even be worthwhile just writing down at the side of your page some of your square numbers. We won't use the number 1, but we might use the numbers 4, 9, 16, 25, 36, 49, and perhaps numbers larger than that are going to be a little bit difficult. But those are some of the square numbers that we will be using. So how do we do this? Well, it's a little bit of a combination of one of the things that you saw a moment ago in the starter activity, where a square root works for multiplication. So what I'm going to do is I'm going to take the square root of 40 and look for two numbers that multiply to make 40. Like 1 and 40, or 2 and 20, or 5 and 8. But I need one of them to be a square number. Well, I know that 4 times 10 is 40. And 4 is a square number. And the square root of 4 is 2. So this is the same as 2 times the square root of 10, which I will write like that. And I will read that as 2 root 10. Now I know what one or two of you are going to say in this topic. Sir, that looks more complicated than that. And yes, visually, it might look more complicated, but the goal of simplifying a surd is to make the number under the square root as small as possible. Let's look at another one. Square root of 150. Can you see one of these numbers that is a factor? Always try and find the largest one. A little bit similar to cancelling a fraction. If you don't find the largest common factor, the highest common factor, you might have to simplify it over several steps. Okay, well, I can see 25 goes into 150. So I know that this is the square root of 25 times the square root of, well, how many 25s go into 150? It is 6. The square root of 25 is 5. So I can write this one as 5 root 6. Let's look at the square root of 32. Now, 4 is definitely a factor of 32, but there's actually a square number that is a larger factor, and it is the square root of 16. How many 16s make 32? It's 2. So I can write this as the square root of 16 times the square root of 2. The square root of 16 is 4. So this one is 4 root 2. There's no need to write this down, but let's say you hadn't spotted it was 16 and you went for 4. And you said to yourself the square root of 4, or 4 times 8 is 32. You did the square root of 4 and you wrote that as 2 root 8. Now what you might see is in the square root of 8, there is still another square number factor in there. So you could break down the square root of 8 again and eventually get to the answer 4 root 2. Quite often I see students with answers that have a root 8 in them or a root 12 where they haven't cancelled the surd as far as it goes. They haven't put it in the simplest form. So, square root of 98, that is the square root of 49 times the square root of 2. Because 49 times 2 is 98. So remember, looking for two numbers that multiply to make that, but one of them needs to be one of these square numbers. So that is 7 root 2. Now, when you get quite good at simplifying a surd, you can actually start adding and subtracting surds. But hang on a minute, sir. You said you couldn't do that. You can't add and subtract surds. It didn't work. You were right. It doesn't work in the conventional sense. However, we can add and subtract surds if they are multiples of each other. Just a little bit like where in algebra we say that 2t plus 6t is 8t. Because we have 2 of something and 6 of something, we can add them. We have 8 of something. So as long as my surds are the same, I can add multiples and I can subtract multiples. So for example, if I had 2 root 5s and another 6 root 5s, well, altogether, I would have 8 root 5s. If I had 10 root 3s and I tried subtracting 3 root 3s, well, 10 take away 3 is 7. I would have 7 of them. I would have 7 root 3s. But how about this one? These square roots aren't the same. I can't add them and say it's the square root of 78. However, a minute ago, we took the square root of 75 and wrote it a different way. Because we said that that is the same as 25, the square root of 25, times the square root of 3. So that was 5 root 3. And you can see actually they are multiples of each other because it is 5 root 3 plus 2 root 3. And if I have 5 of them and another 2 of them, I will have 7 of those root 3s. How could I do this one then? Well, I need to see if I can write both of these in a different way that ends up showing they are multiples of the same surd. So the square root of 72, you might be thinking 9 times 8, there's actually something bigger. We have the square root of 36 times the square root of 2. So that is root 72. I'll tidy that up in a minute. And the square root of 8 is the same as the square root of 4 times the square root of 2. So this first one, because I can do that square root, is 6 lots of root 2. And this one is 2 lots of root 2. So altogether, we have 8 lots of root 2. I do realise with all these square roots flying around, it does look quite scary, but it isn't as complicated as it might seem. We are looking for numbers that multiply to make that number under the square root. So there's a selection of questions for you to try. Some easier questions where you are just simplifying, a little bit like my first set of examples. And then some other questions where you are then trying to add and subtract by simplifying first. Try and get them written as the same square root. Remember, if the square roots aren't the same and you cannot reduce them to something where they are multiple of the same root, you just cannot add them. You cannot simplify it. Please remember to use the last 5 minutes to check your answers. Use a different coloured pen. Make any corrections. If you have gone wrong, can you spot why you have gone wrong? Do you need to ask a question? As always, I will be available in the Ask the Teacher channel.